Welcome everyone to Imagining 2050, a look back at how we arrived at zero. My name is Niva Thongkham and I'll be moderating the session today. We have planned to go for 20 minutes with time for questions, but we'll also make the recording available for anyone who has to leave early or wants to review the webinar. We have the usual webinar functions for our audience to use. Please type your questions into the question box and we love to have your input. Our presenter today is Tia Gaffney. Tia Gaffney is a principal professional leader in the transport safety team here at ARRB. She is a mechanical engineer who has worked in the transport safety field for nearly 20 years. Her love for road safety has brought her all around the world, where she has worked at a grassroots level to provide realistic and practical solutions. Tia has investigated hundreds of serious injury and fatal crashes as a forensic engineer. She has seen firsthand the results road crashes have on our lives, which drives her core belief in the safe system for transport, the ideal that achieving zero deaths and injuries is possible. Welcome, Tia. I'll hand it over to you now.
Thanks, Niva. 60 minutes and we'll have time for questions. Thank you everyone for joining us. This is called Imagining 2050, a look back at how we arrived at zero. Imagine we have arrived at the year 2050 and we now have a safe transport system. Apart from rare occasion, there are no longer deaths and serious injuries on the road. What does a transport system without road trauma, what we would call a safe system, look like? How is a safe system a more livable system? This presentation takes a historical look back at the past, focusing on the steps taken to achieve substantial reductions in the road toll. Just a quick look at the content in this webinar, and I hope you all stay with us for the duration. We're going to talk about the evolution of the safe system, leadership in local government, modal shift and transport safety innovation. We'll look at some, not all, but some of the technological innovations that made a big impact. And finally, some of the rules and regulations that really drove us to zero. First up, let's revisit the safe system and discuss how it's evolved toward 2050. Here we see who most in the industry deem the grandfather of safe system thinking. This is Hugh DeHaven, the founder of the Crash Injury Research Project at Cornell University circa 1942. DeHaven found by investigating World War II survival and crashes that the human body is capable of withstanding large applications of force and energy if there is enough ride down provided, which we now have seen eventuated in seatbelts, airbags, crumple zones, and even wire rope barriers. Here we see each of the individual pillars of the safe system, with the road, the speed, the vehicle pillars, each contributing to both crash avoidance opportunity as well as impact crash mitigation or impact energy management. While the human element is only capable of influencing the avoidance aspect. So unfortunately, unless we're the Flash, Superman, we're unable to influence how the energy is managed once we crash. The post-crash response obviously only influences the post-crash effects, and this is the difference between each of the pillars. Global experts convened in Sweden, and together they demanded a 50% reduction in fatal and serious injury, or what we call FSI crashes, over the decade from 2020 to 2030. To achieve this would require a more holistic evaluation of safe system performance, one where the performance of each pillar is evaluated in concert with the others, and the effects being complementary rather than isolated. In 2020, Australia's focus shifted from the evaluation of individual pillars to a holistic safe system scoring. The safe system score is a combination of the star rating performance for each pillar, with consideration to the contribution of each pillar to the no crash outcome. At a time when the road and the vehicle performance were not yet optimized, such as was the case in 2020, there was a large reliance on the contribution from the user to drive optimally at all times and for the emergency response to occur swiftly and efficiently. By 2021, following recommendations made by experts to the National Road Safety Strategy, a national blameless investigation framework was developed for evaluating and predicting crashes. This again followed a holistic approach where the performance of the system was evaluated. This framework was based on a similar model by Stigson et al., Tingvall et al. In Sweden, and allowed research to determine the contribution of each pillar to the outcome and allowed for theoretical predictions to be made about how future funding could be optimized to achieve FSI reductions. By 2030, the complementary attributes of the road and the vehicle have evolved. They've taken the majority of the load and the burden for crash prevention and mitigation. This allows some amount of driver error or delays in response time. Some of these technological advances will be discussed later in this webinar. Here we see how the traditional hierarchy of controls, well known in risk management, particularly in the workplace, applied to the road environment. We can see here very clearly that training, education, and enforcement of road users sits relatively low in the administrative level on the hierarchy scale. Rather, elimination of hazards or providing engineering solutions results in significantly greater reduction in crash injury risk. Beyond 2020, experts begin to consider loss of control events in what is deemed a bow tie model, where on the left we see reasons why a loss of control event has occurred, such as excessive speed on a curve, texting, overtaking. When we apply a series of barriers to present these circumstances, for example, in the case of driving too fast, we implement mobile point-to-point cameras, which is an administrative control as shown in orange. An in-vehicle speed limiter, which would be considered an engineering control, shown in yellow, and some other advanced safety features like ESC and lane keep tech, also considered to be engineering controls. We're able to diminish the risk of such a speeding event considerably. On the right-hand side, shown in purple, we see our potential outcomes when we have a loss of control on a high-speed road. If the result is running off the road into a tree, we apply barriers of seatbelts and airbags, which are engineering controls, a roadside barrier, which is again an engineering method, or we can remove the tree entirely, which would be the most effective elimination control measure. This model of evaluating events is effective because it allows us to consider which controls are desirable and practicable. As we targeted 50 by 30, meaning a 50% reduction by 2030, we required improvement in risk models. So artificial intelligence, data mining, machine learning spurred this evolution, which led to more accurate models for predicting crash risk and resulting prioritization for rollout of infrastructure and safety treatments. These models rely, as they should, on safe system analysis of historical crashes, and I'll discuss things like black spot treatments a bit later. This is combined with the predictive models such as IRAP, ANRAM, IRR, Safe System Assessment Framework, or SSAF, and as I like to say, is anyone else TOA? Tired of acronyms. Various methods and advanced economic models can be applied to consider treatment options with the goal of achieving the greatest FSI reductions for the smallest financial cost. This is an iterative model. It must always evolve and always keep us honest. In the next section, we're going to discuss how leadership and local government helped us drive towards zero. I'm just wondering if there are any questions from the audience.
Not as yet. I think they're doing gross is what you have.
Okay. All right. So looking at local government and how leadership in local government helped us drive towards zero. By 2020, it was clear that rural and regional Australia faced high FSI rates in two main environments. The first being high-speed undivided roads, and this is obvious to most who travel in the countryside in Australia. This is where we saw high incidence of runoff road, head-on, uncontrolled intersection and motorcycle crashes. The second being urban intersections, and I do include the word urban to describe local city centers. So this is rural city centers where we have more of an urban environment, where we saw high incidence of crashes involving vulnerable road users, particularly pedestrians, cyclists, and motorcyclists. By 2020, it was very clear that Australia would never get to zero without serious contribution from local government. By 2025, councils across Australia pledged to become towards zero cities and municipalities, doing their part to become towards zero champions, starting with the implementation of clever low-cost treatment options. And the beautiful thing about safety leadership in local government is it gains momentum very quickly. Here in 2016, on the left, we see Mornington Peninsula, one of the first councils to become a towards zero municipality. They have begun slashing speed limits with wide public acceptance and challenged the comments that all roads or that the public must always have high speeds on rural roads. It wasn't the case in Mornington. Mildura also had some innovative layouts in their towards zero advocacy, implementing some low-cost roundabouts where they were able to get many roundabouts in the area for the price of one. On the left, we see what many country roads used to look like. Standard centerline, poor surface, 100 kilometers per hour speed limit, no barrier protection, and a very high foreseeability of head-on and runoff road crashes and motorcycle crashes. And I'll just note that a crash did occur at the location on the left. This is above the human tolerance to impact when striking another vehicle or a tree. Whereas on the right, we see some low-cost treatment options that were implemented, including wired centerline with audio tactile line marking, high friction surface characteristics, and a reduced 80 km per hour limit, which was set in accordance with vehicle operating speeds in the area and a corresponding public awareness campaign. Evaluation revealed that there were many roads in Australia which were not so-called mobility corridors, which were mainly used by local traffic accessing residences. For these shorter sections of road, changing the speed limit from the default 100 kilometers per hour to the 70 kilometers per hour limit set by human tolerance to impact in a frontal crash gained acceptance by the public when it was demonstrated that the increase in journey time, which for a 10 kilometer per hour long road equates to about 2.5 minutes of extra travel time. This was an acceptable trade-off for reducing FSI crashes. Next, we're going to talk about how a modal shift resulted in a demand in transport safety improvements. I'm just wondering if there's any questions yet.
Sorry, I forgot to turn my mic up before. We do have one. It's a little bit of a long one. It comes from Corey, and they've asked, I'm surprised user avoidance was simplistically described as tell the driver not to hit the tree. Driver behavior aspects of hazard perception, risk identification, risk tolerance, and behavioral change techniques are potentially far more significant than engineering, substitution, elimination. Shouldn't we include driving behavioral change as a key initiative?
Absolutely. Driving behavioral change is a key initiative, and it always will be. I think the point that I am making with the hierarchy of controls is that it is an administrative control. So that is the fact of the matter. It is an administrative control, and there are other methods in the hierarchy of controls that have a greater effect. That's the point of that graphic. I am not going to say that training or education or any other user, it will always be important. That's not the focus of this specific discussion.
Great, thank you, Corey, for that. We'll keep going for now and take more questions later.
All right, so next we're going to talk about how a modal shift resulted in a demand in transport safety improvements. By 2025, people and not vehicles become the center of transport planning, and this is known as human-centered design. So human-centered design is an approach to creating solutions based on problems and opportunities through a focus on the needs, context, behaviors, and emotions of people who use the system. So shown on the left is a very vehicle-centric system, which is GM's Futurama from the 1939 World's Fair in New York, which some people may recognize when they think of the freeway on their way to work or on their way home. This is compared to a more human-centric system shown on the right, which is a typical carless place, which does have mobility options as well as place options. This process of human-centered design focuses more on the personal journey of an individual and how successfully they get from A to B and how they exist in a place once they arrive, rather than the solutions which solely benefit the mobility of the automobile. By 2020, engineers continue to target the last mile. In 2001, Segway set out to change this last mile of travel. The company encountered some roadblocks in 2010 when the machines began to be involved in some fatal incidents, culminating in the death of the company owner who fell off a cliff while operating his Segway. By 2020, the problem of the last mile remained, with Segway now evolving into a new micromobility scooter market. An influx of crashes involving micromobility scooters spurred new engineering guidelines for regulation. Guidelines like these ensured that micromobility could safely integrate with other transport modes. Everyone can certainly get on board with protecting the health and safety of children. No death of a child on their way to school is acceptable. In 2020, a push for safer travel journeys on routes taken by children to and from school led to an influx of pedestrian and shared paths, cycling routes, protected intersections, and reduced school speed zones. These innovations encouraged more children to walk and cycle to school, where they previously had to be driven by their parents. This improved the health and fitness of our kids and the happiness of our children. By 2020, it was clear that fatal and serious injury, or FSI again, involving vulnerable road users were on the rise, with these groups being particularly vulnerable at intersections. By 2030, engineering designs at intersections, what we now know as protected intersection layouts, have evolved to provide additional protection for people traveling outside of vehicles. On the left, we see a 2020 example from San Francisco, in an area where cyclists demanded a modal change and was realized by the city in planning. By 2020, it was obvious that implementing roundabouts would lead to less severe crashes for vehicle occupants. However, an increase in crashes involving vulnerable road users at some locations spurred the generation of vulnerable road user priority layouts. Giving priority to unprotected pedestrians rather than to vehicles was a new way of thinking for Australia, but one that had been common in places like California, the Netherlands, and Sweden for decades. In 2020, over half of the fatal crashes occurred between a vehicle and a vulnerable road user. By 2050, various modes of transport are completely segregated in accordance with the hierarchy of hazard control, as shown in this image of future London. We can see all the modes of transportation are separated and really flowing on different planes and in different lines. In areas with high pedestrian traffic, segregation between vehicles and vulnerable road users resulted in dramatic decreases in crash risk. This segregation promotes pedestrian and cyclist activity, and it promotes health and well-being. And it is truly beautiful to look at. On the left, we see an example in 2020 in China and an elevated circular walkway in Shanghai. By 2030, transport begins to become truly multimodal. Micromobility options and pedestrians now have designated travel lanes. Shuttles are crowdsourced by a mobile phone rather than running on set routes. Autonomous vehicles operate at level 4, and many vehicles are electric. There is more access to public transportation, and all these features result in minimized need for parking, allowing for more green space. I will, for our listeners, highlight that this example from Ford, that motorcycles are still relatively unprotected from cars and other hazards. Next, I want to highlight some of the technological innovations that led to a step change in reducing FSI crashes. I'll again ask now at this break for questions.
I think people are still just want to hear what you're saying, so we'll just give them a little bit more time.
Okay. All right, so by 2050, transport is no longer linear. So engineers and designers stop thinking linearly, and transport design becomes, again, human-centric rather than vehicle-centric. So vehicles speak to each other. They speak to infrastructure. Mass transit is efficient and high speed. Drones deliver everything from food to mail to medical supplies. Shared transport allows for a reduction in vehicles, more parking and less congestion, and more green space. And pedestrians can now cross the road safely without the need for traffic signals. This is again from Ford. By 2030, there is a significantly greater proportion of autonomous and electric vehicles. Initially, possibly, cabs will travel in a designated lane, requiring engineering innovations in line marking and signage. By 2030, line marking and signs must be engineered to ensure cab effectiveness. On the left, we see an example of a typical line, and then a line with advanced retroreflectivity after 2 minutes of rain. We can see how difficult it is to see the line on the left, how easy it is to see the line on the right. Any technology for cabs is also beneficial to human users, and so advanced retroreflective line marking began to be implemented by 2030. Future road signs may not need words at all. We might have barcodes on the sign, such as on the sign designed by 3M on the right. By 2050, roads are now prefabricated from recycled materials, which optimizes structural and surface characteristics. This example from One End Road to the Future is a bike path trial in the Netherlands. Roads may become waterproof, minimizing crash risks and maintenance costs. In 2020, 60% of crashes occurred at intersections, and drivers used to spend 2 days per year waiting at traffic lights. By 2050, V2V, V2I, V2X technology eliminates the need for traffic signals. This V2V or V2X relationship models the natural slowing down and speeding up used by pedestrians to avoid collisions. And we know that free-flowing traffic saves power and is good for the environment and enables us all to get home faster to see our families. By 2030, intermodal freight may be mainly autonomous, which eliminates workplace injuries and deaths in a very, very high-risk environment. Crashes involving heavy trucks are eliminated due in large part to platooning efforts, which allow a lead vehicle to be operated by multiple operator pilots, working in alternating shifts with following vehicles being autonomously operated. This reduces driver fatigue-related incidents, emissions, and it improves the overall well-being of drivers who are able to enjoy the company of someone sitting next to them, have a chat. This is one of my favorite slides. By 2040, the roads must be free of debris. This is something not everyone's thought of, to ensure that line marking is still readable. Will these vehicles be autonomous? I'm not sure, but certainly we'll need to keep the roads free of debris to ensure that the line marking is clear. By 2030, occupants are now protected in high energy crashes. This is due in part to Volvo's Equal Vehicles for All initiative, which proves that it's possible in its 2001 XC90 design, which has not been involved in an FSI crash ever since its inception. On the left is an example of a 2020 XC90 involved in an 80 km/h offset frontal impact. Volvo has vowed to see the 0 fatal and serious injuries in any new Volvo manufactured after 2020. We'll see how lucky they are in accomplishing this. The structural crashworthiness of this vehicle is amazing in the crash test, as you can agree. And you can see the amazing crash protection capability of a vehicle and what this would then mean for setting speed limits in environments. By 2025, Australian design rules mandate avoidance features such as AEB, corrective cruise control, and lane assist. This technology prevents up to 70% of crashes. And by 2025, it will be the vehicles and not the drivers that are avoiding the crashes. When crashes still do occur, vehicles will be designed to be pedestrian friendly. By 2025, vehicles sold in Australia are required to have a certain level of pedestrian protection, and the majority will exceed 5-star rating for ANCAP's pedestrian protection test. By 2050, motorcyclists are safer on the road. Motorcycle stability control technology regulates brake pressure to reduce loss of control. Helmets may be designed with advanced non-Newtonian materials, and motorcycle-friendly crash barriers are installed, which I'll touch on further in a minute. And I'm not going to lie to the audience, this is a tough subject without going through, again, administrative controls. And so I've not touched on that here, but I do acknowledge that this is a difficult issue for drivers and motorcyclists both. Many crashes involving motorcycles involve look but fail to see events, or sorry mate, I didn't see you, which we now know as SMIDSY. Anything improving the driver's visibility or the visual connection between the driver and the motorcyclist should be initiated to ensure that this type of crash risk can be reduced. On the left, we see an example of a Mercedes see-through virtual A-pillar design, which displays what is missing in the gap of the A-pillar that the driver can't actually see. You can see a pedestrian there. By 2030, vehicles are designed to prevent wheel slip, and skid resistance of the road is measured in real time. Here we have a BMW xDrive, which measures wheel slip. This data is captured to monitor road surface data, road condition, slipperiness. Slippery areas are immediately rectified by road authorities based on real-time data. This prevents the need for reactive maintenance and allows for proactive maintenance to be executed. All right, again, I will stop and ask if there are any questions from the audience. I would love to have some questions because otherwise I'm going to finish early.
Yes, we do have some questions actually. This one comes from Shendi, and they've asked, hang on, just scroll up. Do you know how the Mornington Peninsula Shire Council slashed speed limits without public outcry? Can you comment on this?
I do. Well, I probably don't know the entire gamut of the story, but I know what I heard Mornington Peninsula say. They did a lot of surveys of what the vehicles were traveling on those roads. So the actual travel speed of the vehicles was not as high as maybe some people thought. So I think that's the case a lot of the time, is that when we have a limit that's 100 km/h, people assume that most vehicles are traveling 100, and in many cases they're not. Many cases the road may warrant a travel speed of 80, and the majority of vehicles may be going 80, although the speed limit might be 100. So that was produced, and they did have a lot of consultation with the public, and I think they were surprised actually to find how accepting the public were of the reduction in speed limit that they ultimately have generated there. So I think it's a really good outcome.
Oh, great. Actually, we've got a whole ton of questions coming in now. Let's see. This one comes from Stacey. She's asked, how is it proposed to modify the thinking of the drivers who like classic vehicles that do not have advanced safety features?
Yes, so this is a good question that we had from Alan Hay in our last webinar, and we had quite a discussion on this. Again, just to remind everyone my background, I'm from the Detroit area. My whole family's from Detroit, and I am a great lover of historical vehicles and vehicles in general. It's a difficult question, and I don't really have a great answer. For me, I've investigated lots of crashes where I've seen the effects of what happens to a historical vehicle in a crash, and I've actually been involved in a crash where I crashed a 1978 Corvette myself that I was driving. Let me tell you that fiberglass does not do well in a crash, nor did the seatbelts that I was wearing at the time. And so, yes, these are all questions. Is there a perfect solution? I'm not sure, but I think it needs to be discussed. Whether or not they'll be allowed on the road, I'm not sure. Whether or not you'll have to possibly pay some money if you're injured, I don't know the answer. And I think it's something that needs to be discussed. But I certainly don't want to see a time where there's no beautiful cars driving down the road and everything looks like a robot either. So
Yeah. Do you want to do one more before we continue?
Sure.
Okay. This one. I've just lost it now. Okay, this one comes from Jerome. He asks, are the motorcycle crash barriers now required to new projects in most highways?
So there is a requirement that they must be considered in areas where we have a high motorcycle, where we have a lot of motorcycle travel. So certainly when you're installing a barrier on a road and you've got you know that there are a lot of motorcycles in that area, yes, you need to consider whether or not it's feasible or practicable to implement that design. I would love to see them on most, rural roads where motorcycles are traveling, because they do have a great outcome, safety outcome for motorcyclists. Yeah.
Yep. Great, cool. I think we will carry on. We do have more questions, but we'll save them till later.
All right. So again, this doesn't cover every single change, and I think there will be a lot of information here about how rules and regulations, policy, all that have evolved from 2020 to 2050. I'm just going to touch on a few that I think are important. So by 2020, mobile phone cameras are installed in New South Wales, and this is a photograph of what the image looks like that comes from a mobile phone camera in New South Wales. You can see it's very easy to tell that there's a camera or a phone being used. What I think is more important actually in this photograph is that we can tell whether or not the occupants are restrained, whether or not they're wearing their seatbelts. And this is something that was highlighted when these images first came out of the mobile phone cameras. And I think in 2020, with such a high incidence of people who are unrestrained in FSI crashes still happening, it's very important to make note of this restraint use in these photographs, and that's something that occurred. On the right, we see a pedestrian with a mobile phone, and in the 2020 timeframe, this is a real problem. So a lot of pedestrian crashes at intersections are occurring because people are not alert. They're looking down at their phone. They're not looking at traffic. And so it is no longer, by 2030, legal to use your phone on a road, period. So whether or not you're a pedestrian, cyclist, motorcyclist, driver, if you're on a road, you shouldn't be on a phone. The mobile phone data was used to monitor movements of pedestrians, movements of cyclists, movements of vehicles in order to really understand this multimodal relationship. And that's something that happened starting in 2025, but going into 2030. Vehicle and mobile phone data is now monitored in real time by 2030. So we have a network where we can actually look at the real-time speeds of vehicles. And then these vehicles' speed can be limited to the posted speed limit by engineering controls. So the technology existed in between 2020 and 2025, where vehicles can actually now read the speed limit on the road and then are able to actually limit the speed of the vehicle based on the speed limit sign that they see. So the system is being constantly audited by this data, and it's really the generation of big data that changed how speed is monitored and controlled, and that had a very, very large effect on what ultimately happened. So any anomalies in the system, as soon as we start to see red hot spots where people are speeding, or where we have a lot of high friction events or high lateral acceleration readings, we're able to go out and look at what happened on the road there, and we might see that there's a large pothole in an area, or that the area has become slippery, and we're able to amend that before a crash has occurred. In 2020, it is well understood that drivers reduce speed at known camera locations. In many cases, speed might increase somewhat downstream. And on the top right, we see a graph of that, where we see the speed of a vehicle approaching a speed camera, where we know a speed camera exists. The speed drops right down to the limit and then back up again. This phenomenon is known as the halo effect. By 2025, mobile point-to-point, also known as average speed cameras or mobile average speed cameras, were deployed across Australia in an attempt to eliminate this halo effect. These cameras are deployed randomly with the goal of deterring speeding on a wide scale and with a wide geographical reach. The probability of a driver encountering this type of enforcement was high, which resulted in very good speed compliance with the majority of the population on 100% of the roads on 100% of the time. By 2030, vehicles are capable of detecting alcohol and drugs in drivers with in-built base systems. These are OEM systems that are utilizing technology that existed far prior to this day, but that they're now implemented such that the driver is required to breathe into the steering wheel device before the vehicle will start. By 2030, fatigue is successfully measured in police roadside testing, just like drugs and alcohol are. So this testing is made possible through studies that have quantified physiological effects of fatigue in road driving environments. On the left, we see a VRUS and Monash trial commenced in 2020 to measure fatigue in a roadside test. We also have OEM technology from heavy fleet operators and typical fleet operators measuring the eye movement, signs of fatigue, and as soon as this occurs, the driver is told to pull over and rest. Researchers began to realize that maintenance intervals set for automobile traffic may not be applicable or appropriate for motorcycles. This initiated the response of dynamic maintenance intervals on motorcycle heavy routes. On the left, we can see a road defect that may or may not be hazardous to a vehicle, but may be quite hazardous to a motorcycle. We can see that this defect may not have been amended as per the scheduled routine maintenance that existed. However, with new dynamic maintenance with motorcycle priorities, this is something that would be amended much quicker on a motorcycle route. In order to achieve reductions in motorcycle-related runoff road crashes on high-speed roads, motorcycle-friendly barriers were installed. This was touched on earlier. In 2025, the federal government has revised the Blackspot Criteria to include a more robust risk-based approach. Funding is allocated to corridors with the greatest safety risk, and that's historical and predicted risk. And the computer-based algorithms are used to predict the most effective methods for spending available funding. This is a very important slide. With vehicles no longer being manufactured in Australia, possibly, Fleet operators realize they have a duty of care to the Australian public to demand better, safer vehicles and vehicles with advanced and autonomous safety features. What you buy, we buy. It is understood that vehicles purchased by fleet operators will shortly filter into the hands of you and me, our neighbors, friends, and children. The performance of vehicles in the safe system was entirely dependent upon the choices made by operators of large fleets, and our future safety depended upon your brave decisions. Unfortunately, it is not yet 2050, and there will be as many as 1,200 road deaths this year. At least 50 of these deaths will be children younger than 16. At least 250 of these deaths will be youth less than 25. Another 250 will be young professionals, aged 26 to 39, and so on. I hope this presentation has sparked new thinking in each of you. Thank you for coming on this journey with me to the year 2050, when there are no more deaths or serious injuries on the road in Australia. I encourage you to be a believer, to be a safety champion. It is worth it. We can do it if we do it together. So I'm a bit early finishing. I'd love some questions if anyone has any.
That was fascinating. Thank you so much. And we have an influx of questions, so just trying to filter through them all. We've got quite a controversial question come through from Lachlan. He's asked, if a pedestrian can't cross the road while looking at their phone because they're not looking at where they're going, should people with vision impairment be legally allowed to cross the road?
Of course, of course. So people with disabilities absolutely have the right to equal and equitable mobility, and really it's equal mobility for all. So it just means that we need to implement solutions for people who are have visual impairments, for people who have physical impairments, for people who have any sort of disability whatsoever, and that is an absolutely necessary thing, and it really it highlights that focus on human-centered design. So it's about, thinking about every single thing that we design, and am I a driver? Am I a pedestrian? Am I a person with a disability? Am I a mother with a pram? Am I a mother with kids? Am I a cyclist? Who am I? And does this meet my needs?
Yeah, definitely. I think I definitely agree with you there. We have another one here from Frank. So regarding fatigue testing, how will that affect people's work targets? For example, truckies who have logbooks, they may need to change their workplace policies and their organization may be liable.
Yes, so obviously fatigue is a huge issue in the heavy vehicle industry, and really not only the heavy vehicle industry, any industry where you have people driving on the road for long periods of time. And so it is a constant battle fight, dealing with fatigue versus profitability. So, you've got companies like Uber dealing with this issue as well, where you've got vehicles on the road for long periods of time. What we need to do is focus on, again, what the people require. So it might mean that they need longer rest breaks. It might mean that policy needs to change. And I understand that profitability is always important, but for me, it is not a trade-off for someone's life. And it's certainly something that needs to be monitored.
Yes, definitely. Okay, next one comes from Ron. He's asked, how important is new legislation regulation if we are to maximize the benefits of 2050, and what provisions are most needed?
Yeah, so again, it's a difficult question, because if you overregulate, then you inhibit technological advances, which is something we certainly don't want to do. So it is that constant back and forth between what industry and technology are capable of giving us, and keeping up with that. And most legislation requires a significant lead time to come in. And so it really is very difficult for all of us in this environment right now, where where transport is changing so rapidly to even understand what regulations would need to come in. And again, I think that's why it's more important to focus maybe on frameworks and, you know, again, like we've got overarching ideologies, I guess, than very specific, don't do this, don't do that, here's a law, here's a law. But there will need to be, I think, you know, starting again, if you look at each pillar, we are going to have some regulation on road design, you know, some more safe system requirements need to come in when you're designing a road, and particularly when you're spending money on a road, it needs to be demonstrated that the road is safe. With vehicles, there certainly will be some regulation, and there will be new, I'm sure, issues coming in where we are going to be accepting vehicles from other countries, and whether or not we are going to harmonize our standards with Europe or America or globally, and then, you know, users, we're going to have, you know, when my kids drive, or are they going to drive, you know, are they going to have a license, or are they going to be more like a pilot where they go into a simulator and they do, you know, tests on hazard, you know, how are they going to respond to emergency, rather than, you know, what you and I do, where we practice parking. So, so that is a very long question to answer, but I think that if everything is fundamentally centered on the safe system thinking, we'll make a lot of ground.
Yep, definitely. We've got another one come through from James, and he has asked, vulnerable road user deaths have been on the rise due to the increase of SUVs and utes and trucks on our roads. In what year do we revise the vehicle design standards to reverse this trend?
Yep. So that's true. Vulnerable road users are vulnerable in any vehicle impact, but particularly with vehicles with a high center of gravity. So that's because the center of gravity of the vehicle is higher than their own, and it really, the impact, they take a lot of the force of the impact in those crashes. Whether or not we're going to be able to mandate the height that a vehicle front end could be, I doubt. But it is important to note that ANCAP is addressing pedestrian protection, acknowledging that many heavy vehicles sort of fall outside of this realm at the moment. And so, yes, I do think there's a gray area where you've got vehicles that are exceeding the GVM, where you have to meet these standards, and hopefully we are going to see some movement in that area. And I think there's a lot of potential. ARRB is working on some projects involving construction vehicle regulations for vulnerable road users, and I think that's a very important thing. So as soon as we start to see influx of infrastructure, you know, influx of heavy vehicles, heavy rigid vehicles, utility type vehicles in particularly in urban environments, vulnerable road users become very, they're the ones who pay the price for that. So we definitely need to consider their safety, and again, make sure that the road is a safe place for everyone.
Great answer. We have another question from Vaughn. Vaughn asks, another big issue with motorcycle accidents are due to the line markings. Have there been any studies in creating more traction on line markings?
Okay, so if this relates to line markings being slippery, certainly the microtexture, macrotexture of the road is one of the most important factors that influences crashes. So the line marking itself, the first question I would ask is, why are we driving on the center line? That's probably not a great idea. But I understand that as a motorcyclist, you are sort of picking your lane, or your what's the word I'm looking for? Your path as you come around the curve. And that is far different from what a vehicle would take. So we are doing a lot of work in the line marking space, looking at the quality of line marking, the texture, and even looking at some new materials to be using in line marking. So different types of paint, implementing plastics, things like that. So the short answer is yes. But we certainly, for motorcyclists, need to consider the friction of the road as a very important parameter to their crash risk.
Great answer. This one stood out to me. Okay, this one comes from Satish, and they've asked, there are so many rural roads which lack lots of technology. How do we address them?
I like that word, rural roads. Rural, are you saying rural?
Rural,
Oh, I thought you
sorry.
said rural,
Rural.
rural roads. Yes, there are many, 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 many rural roads in Australia that need they need safe system improvements. So that is a combination of requiring infrastructure to go in and acknowledging that a lot of rural areas won't have the funding available to implement a full-fledged safe system. So it really is about giving those areas tools that they need to implement as much as they can to get the greatest benefit that they can. And that's something that ARRB is working on as we speak, to be able to give local government some tools to say, here's a section of road, what do I do with it? Should I improve this one intersection, or should I improve the entire length, and how?
Okay, great. And we have another one come through from Rose, and she asks, can you please elaborate on pedestrian friendly? What does that mean?
To me, pedestrian friendly, well, it means ideally pedestrian friendly would mean completely segregated from a vehicle. That is the ideal. So if I can actually take a pedestrian footpath and separate it completely away from a vehicle such that there is no longer that risk of those two things intersecting, that is the most pedestrian friendly option. Other than that, it means, you know, things like raised platforms, so zebra crossings, improve signage, improve lighting. It means that you go out to an area and you consider from a safe system what you would need to do to make this area have a very low risk of a pedestrian crash happening.
Yeah, great. We've got so many questions, so luckily you finished early because I don't know if we're going to get through them all. But this one comes through from Claire, and Claire asks, many of these treatments require infrastructure treatments or close to immediate response. How do you imagine resourcing for these treatments to occur?
I'm going to wave my magic wand and I'm going to, no, this is a very difficult question. And the answer is every FSI crash costs us about between $600 and $650,000. So it is not a small amount of money that we're paying to have these crashes occurring. That's exactly why we need to prevent them, other than the moral obligation of doing so. It is financially and economically a good idea to make the roads a safer place. And as I tried to demonstrate, improving safety doesn't have to be a negative thing or shouldn't be a negative thing. It should be seen as a real, it should be done at the very beginning. So when we know we're going to maintain a road or build a new road or just redesign an intersection, it should be the very first thing that we talk about and the very last thing that we talk about. And I think when we do that, we will find that the funding is sort of inherently within the project funding anyway. And then, you know, there has to be some commitment from everyone, and that's every single one of us to decide that this does matter and it's an issue that we need to improve.
Yeah. Okay. The next one comes from, apologies if I pronounce this incorrectly, Kudus, and they've asked what sort of prediction model has been used and what is the error margin?
Yeah, good question. Okay, there are a lot, and I'm assuming the prediction we mean is in predicting crashes. There are, as I said in my acronyms, there are a lot of different tools that we use. So the first being IRAP, which is the International Road Assessment Program. And then ANRAM, which is, again, a road rating model. And all these models, essentially what they do, they've taken historical crashes and they have correlated those with the types of environments that we know relate to crashes. So things like undivided roads, speed limit obviously has an effect. Things like AADT, lane width, whether or not there's a shoulder, all these aspects go into predicting whether or not a crash is likely to occur at a location, so either mid-block or intersection. And then we can use that model to give us a ranking, or we can use it to say, okay, if I put in a wider center line, or if I reduce the speed limit, or if I add a shoulder, what does that do? And how does that decrease my predicted risk? And then there are ways to add in sort of what's happened historically, so how many crashes have occurred there, and it really sort of, I guess, validates the model in a way. And that's our best method thus far. I personally think that there is a lot of room for improvement here, and particularly with data. So the more data we have, the better we can get, and the use of big data, things like HERE data, mobile phone data, all knowing the actual dynamic speed of a road is going to all just help us improve these models. But it is an ongoing process and something that's probably going to take quite a lot of effort.
Okay, great. This one comes from Ahmed, and Ahmed asks, do you agree if governments invest in public transportation that will make us reach the Vision Zero initiative faster than if they invest more in infrastructure, autonomous vehicles, and the technologies you have mentioned?
Yes, very good question. So public transportation is obviously very safe. We know this. Riding on the bus, riding on the train. The problem is actually not that portion of the journey. It is how are you going to get to the bus, and where are you going to park once you get there? And then are you going to become a pedestrian for a certain length of road? And so it really is about optimizing your journey. So how do we best optimize your journey from A to B to ensure that you arrive there safely? So I do think public transportation is a huge factor, and it is certainly something that we know is going to be needed in Australia. We will have to improve our public transportation, but it's only one part of what we need to do. And again, I touched on a few things, such as once you get off the train, I mean, we work here in Port Melbourne, and to get from the train to our office is not the easiest thing. And some people are hopping on to things like scooters or bikes. And so it's about that whole journey and getting the whole thing.
Great. And the next one is from Michael. So Michael asks, when does road danger reduction or getting people to use a slower and lighter mode for short trips become part of a safe system? Sorry.
Yeah, so well, getting them to do it. I don't know how you can influence, I guess, people's desire to want to get out of the car, other than if you improve. So if I'm able to reach work in 30 minutes by walking and riding a bike versus 2 hours driving my car, it's certainly going to be an easy choice for me to make. So I think it's just about improving infrastructure. Again, we know that cycling is the infrastructure and cycling, there's a lot of spending happening in that area. And it really is, again, about ensuring that there is that segregation. So I don't want to put a bunch of people on a bicycle on a road where they're going to be interacting with heavy vehicles or things like that. So it's about making it desirable.
Great. The next one comes from Chris. He says, hi from Safer Roads program. Are you aware of safety modeling approaches utilizing all 4 pillars of the SAFE system?
I know who this Chris is. I'm aware that there are whispers of this occurring, but I don't know that there is a validated model that is currently being utilized and working that takes every single pillar, being and if it depends on whether or not you include speed, the road, the speed, the vehicle, the user, and the response. I think the response is something that's often left out. So that's not something that I know of that's been considered in any model to date. So has anyone gone in and looked at what is the response time for each of these crashes, and did it have an effect or not, and how did that work, and how do we ensure that there's a much shorter and efficient response? So the answer is I don't know of one that does all 5, but I hope there will be soon.
Great. And another one from Avril. They've asked, what is the privacy considerations for the data coming from mobile phones/vehicles, and what protection is there from hacking or incorrect data?
Yep. Always an issue ethics-wise when we're talking about personal data. I think that as long as we have systems in place that are they're ensuring that data is depersonalized, then I don't see an issue with it. There's always issues when we talk about hacking ethically, and that's just another hurdle that we're going to have to get around. I don't think it's enough of a reason to not use that type of data that we have available that is going to enable us to prevent people dying on our roads.
Yep. All right, we might have time for one or two more. This one comes from Camillo. Many roads have been built using alternative materials such as plastic waste. Do you see any future potential in this?
Yes, so this is an area ARRB is very passionate about and regularly involved with. So absolutely, the recycling of materials, the use of new and innovative materials in the road is a great place to store and keep these materials that we need to dispose of. So absolutely something. And if you want any information about that, contact us here at ARRB. We can give you some more information.
Yes. There was one that I had. I've just lost. Oh, here from Anthony. Sorry, they're just coming through thick and fast. This one is from Anthony, and they've asked, how is the age of the national fleet going to be made younger and therefore safer?
Again, I highlighted in one of the very last slides, and that's one of the reasons it was last. The age of the fleet is largely influenced by some of the larger fleet operators, and you would see that if you ever went out to Pickles to go to an auction, you'll notice the entire room is pretty much one type of vehicle, and that is whatever the vehicle is that's selected by that fleet operator. And so that's what I'm highlighting, is that we really need to put some thought into how much that will trickle down into the rest of Australia, and realizing the importance of every year the fleets that we buy, and we being large fleet operators, that will affect safety for the next 10 years plus.
Yeah. Great. And we'll just go through one more quickly. This one comes from Daniel, and Daniel's asked, to reach Vision Zero by 2050, drastic changes to how we approach road safety are needed. What about some controversial changes like banning motorcycles completely? What are your thoughts on this?
I don't like that word banning, because I think it again goes against the idea that everyone is a road user, and it is, I think it's a personal choice what mode of transport vehicle people want to take. I certainly am not an advocate of banning anything without some thought. I don't know how it's going to evolve. I mean, motorcyclists are particularly vulnerable because they are traveling, at vehicle speeds, but without, things like airbags and seatbelts. And so it goes back to that Hugh DeHaven graphic that I showed at the very beginning, which is, if you can't ride down a crash, you're not going to do very well in a crash. So with motorcycles, it's really more about crash prevention in the first place. So it's about them not being in crashes at all. So again, things like visibility, and anything we can do.
Yep. Great. Well, we've actually just gone a little bit over, so thank you so much for that insight. There's quite a few unanswered questions, so we'll get to them after the webinar. I'll make sure to send a list of questions to you, Tia. So we have a special Safe Driving Easter webinar coming up in April. So when details for this are released, we'll put them on the website and our weekly webinar newsletter, so you'll also be taking us through that. And Tia was also recently featured on our new podcast series, Road Research Radio, which is available on SoundCloud and on our website. So she discusses all things road safety, so be sure to check that out as well. And thank you, Tia.
Thank you very much for having me, Niva.
And thanks to our audience for tuning in. We will see you next time.